Greg Paulson. He's Director of Applications Engineering for Xometry. And Greg, I'm holding an example of two actually very complex parts here. Now both of these could be contract manufactured by a specialty company involved in, say, stamping, forming, bending, or 3D printing, or injection molding. But understand at Xometry, you basically can tap any of these processes.
Yeah, so Xometry is a platform for manufacturing parts. And we keep that very broad. Whether it's CNC machining, sheet metal, urethane casting, or a variety of 3D printing processes, both in plastics and metals. What we do is we offer a website where all it takes is a 3D CAD model. You can upload it directly to the website. It'll give you pricing and lead time for every process instantly as you upload. So if you have a project that has a sheet metal component, a CNC component, and then several of the pieces that are also cast, you can actually upload those parts all in one bill of materials on the site, configure your quote, you see your pricing, your lead time right away, and you just press order, and we take care of the rest.
Now, in case of example, take this part for example. Now this part, this could be formed from sheet. It could also be 3D printed. It potentially could be machined from a solid block of aluminum the same way, but what if I don't know exactly which is the best process for me?
Yeah, so this is what I love. So this is actually a really good piece. I'm going to steal it from you for a second, because with this piece here, a lot of people may think, hey, I need this quickly, so let me 3D print this out of metal. And they'll go and they'll upload it to our site, and they'll click 3D printing, they'll click metal, and they'll see, okay, here's the price in stainless steel, here's the price in alumina, etc. And they can actually see that right there. But honestly, this part is designed for sheet metal fabrication. So I would actually recommend to that customer, check out what the price is and the lead time in sheet metal. It actually may be one extra business day to get exactly what you're looking for. We don't hold a minimum quantity. So sometimes you find, okay, it does make sense to transition from a 3D printing prototype process to a production ready process where then you can make thousands of these parts for you, so we can scale up from your one-off all the way to thousands of units. But sometimes, yeah, it just makes sense to get straight to the point and make that. And we can do that all through our website and show you those trade-offs and feedback right away as well.
Now, we talked about metal. This example of a resin part. And resin parts, of course, it's the problem of metals on steroids, because you have an incredible number of materials, a number of sub-varieties of materials, filled, unfilled, etc. And again, in processes, you could 3D print this, you could injection mold it. In some cases, you could actually still machine it out of a block of solid. Is the same thing apply with plastic parts as metal parts?
Yeah, so actually it's really interesting. When I look at a plastic part, and I'm going to ask you a couple questions usually about when you need it by, what type of trade-offs are you open to, because we can make something that is exactly as you need it. And we're always expanding our platform, looking at new technologies, and even more scalable technologies like injection mold, for example. But say you're looking at something in the quantity 20 to 50 range, you may ask yourself, does this make sense for me to move to urethane casting, which is an extremely robust end-use manufacturing process that's kind of a subsidiary of 3D printing, where you're using a master pattern, making a mold, and then injecting urethane to create your parts out of it. But you also may be able to go direct to a digital manufacturing process like 3D printing. I find for more organic shapes like this, with high levels of complexity in multiple directions, so you can see this is shooting this way, and this way. Our SLS process, which is a powder bed fusion process of sintering nylon together, is a really, really good choice. Where if you have something that's kind of broader, chunkier, you may want to look at something more like our FDM process, which is a filament-based process, zigzagging back and forth. And in that case, we can build something real big for you.
Greg, do customers know what they want?
Some do, and those people usually provide a drawing for that, and that's what I found. But a lot of times they're still looking, and actually this is something I found is there are more people now that have access to 3D CAD modeling that are getting into manufacturing, because now 3D printing and other technologies and websites like Xometry, we're actually able to get you that quote right away, even if it's not manufacturable. Like we can say, well, in 3D printing, we could do this. So we have more 3D CAD modelers now, and that's not necessarily trained 3D CAD modelers. So do they know what they want? There's a lot of learning there. Do we have content on our site to help them? Definitely. Our design guides and our FAQ are a really good place to start for that.
So it sounds like I don't need to completely finalize my design before I approach you.
You can start pricing right away, but keep in mind when you press go, that's what we're making for you. So I think with the commoditization of additive manufacturing, what you can do is kind of the shotgun approach, or at least prototype a feature of your major design. So you want to see how this hinge works, or you want to see how this grip feels in your hand. Like, this is something that you can actually prototype very economically now, where it used to be very cost prohibitive to do so. Analogy that I use a lot is with digital cameras versus film, where before you had 24 shots, and you really were careful what you're taking here. Now it's like a digital camera platform with digital manufacturing, like 3D printing, where you can take a bunch of shots and get something usually a lot better than what you do if you were just limited to those 24 on your film. So I really think this opens up a better design and a better outcome for a project that you're building too.
So it sounds like the lower cost lets you design iteratively in a way that you just cost prohibitive before.
Low cost and quick lead times. Those two things together. Yeah.
Low cost and quick lead times allow you to design iteratively and try things that you would never be able to cost effectively try before, says Greg Paulson at Xometry.